Hello, everyone, and good morning or good afternoon, wherever you may be coming from us today. My name is Morgan, and I'm a program manager here at Change Chemistry, and I'm super excited to welcome you to part 3 of our webinar series, delving into microplastics and microfibers and how we can collaborate to solve this challenge and other sustainability challenge. Before I kick it off and hand it over to today's speakers, I want to set some quick ground rules. First and foremost, please know that this webinar is being recorded, and all of our meetings and events follow antitrust rules. So if you think there is any issues today regarding antitrust rules, please contact me as soon as possible. Our meeting today also follows the Chatham House rule, which means that you're free to use any of the information you receive, but the identity or the affiliation of the speakers or any other participant on today's call should not be revealed. To help us remain compliant with the Chatham House rule, we ask that you do not use any AI note-taking tools today. So if you are using any, please turn those off now. We will be sending out a recording of this webinar afterwards. So if you feel there's anything you miss or want to go back and review, you will be able to go back and look at that recording. We will have a designated Q&A time as well. So if you have any questions that pop into your head throughout the course of the webinar, please put those in the chat box and I'll ask those to the speakers. Otherwise, please stay muted throughout all times during the course of today's webinar. And before I hand it over, I also do want to give a quick overview about who Change Chemistry is, in case we have anyone joining us for the first time today. Change Chemistry is a business organization focused on accelerating the adoption of safer, more sustainable chemistry throughout the full chemical value chain. We envision a global economy where all chemicals, materials, and products are safe and sustainable from their creation through disposal and reuse. We work towards this goal by building a community of change and fostering strategic collaborations, cultivating first movers, working with decision makers in industry and the investment community, and advocating for supportive policy. We have over 125 members that work with us towards this mission, and they span the full value chain, encompassing large chemical manufacturers, retailers and brands, startups and consultancies, as well as nonprofits, policymakers, and the investment community. We work towards key sustainable chemistry topical issues that we identify alongside our community to really drive actionable change in this space. With that said, I do want to give a quick shout out to three new projects that we have this year that were identified as key topics by our members. The first is Future Fit Materials, which is a group that's going to be looking at plastics specifically to kick off. Our aim is to understand priority applications, identify alternatives, and develop a strategic plan that we can actually use to implement these alternatives in the marketplace. The second project is Sustainable Solvents, which is going to kick off by looking at solvents in consumer-facing products. In this project, we will work to identify functional alternatives that are safe and sustainable, and also address some of those barriers for those products being commercialized. Please note that both of these groups are for members only. So if you are a member and you're interested in joining, we encourage you to join our January 28th Supply Chain Working Group meeting. If you did not receive the invite or needed to be resent, please contact me or Jenny. Lastly, I want to quickly introduce our Transatlantic Working Group on Policy Incentives. This group is going to examine lessons from existing US and EU policy incentives that span the full policy and the full value chain so we can make recommendations for practical incentives. Again, this group is for members only, so if you're a member and would like to attend or participate, you can scan the QR code on the screen in order to attend the kickoff webinar on February 20th. If you're not a member and you're interested in any of these projects, I encourage you to reach out to Jenny, myself, or anyone else on the team, and we're happy to chat with you about becoming a member and potentially joining these projects. But moving on to the topic of today's webinar, and while we are all here, microplastics and microfibers. This is another key topic for our community because of microplastics and microfibers' global prevalence and potential human health effects. and because they've been garnering a lot of attention in the media and the community at large. However, in the wise words of Marie Curie, one of my favorite scientists, now is the time to understand more so that we may fear less. At Change Chemistry, we work towards this by trying to dive into the chemistry behind our products and materials and understand how they can be optimized and best understood so we can develop solutions to these global sustainability challenges. We already had 2 parts of this webinar series so far that we're looking into exactly this. So if you're interested in watching either of those parts, you can do so by scanning the QR codes on the screen. However, don't do that quite yet because we have some really great content lined up for today. With that said, I want to introduce our speakers. First, we have Elliot Bland, who is a researcher at the Microfibre Consortium. And then we have Analoli del Cueto, who is a junior consultant at Ohana Public Affairs. Elliot and Analoli, we're really grateful for you taking the time to speak with us today and share your insights into this really important topic. And with that said, Elliot, I'm going to hand it over to you to kick us off with today's content.
Thank you. I'm Elliot Bland. I'm a researcher at the Microfibre Consortium. I'm going to speak about microplastics, microfibres, fibre fragmentation, and how Microfibre Consortium and the textile industry are working to address the topic. So next slide, please. Oh, can I do this or do you have to do it? Oh, yeah. So microplastics, as you will know if you've attended the first 2 sessions, are fragments of plastic with a size of less than 5 millimeter. There are many sources and types of microplastics to the environment. What I'll be discussing today and what we focus on is microfibres in specific. So microfibres are fragments of textile fibres released from textiles into the environment as a result of mechanical or chemical stress. Microfibres are one of the most common form of microplastics found in the environment. Many environmental studies show that microfibres outnumber other microplastic types like fragments or film or spheres. The term microfibre is also used within the textile industry to define a very fine fibre. That is not what we're discussing today. It's a separate topic. So because of the confusion with a term that is used for something else within the textile industry, the term fibre fragment is sometimes used instead. So microfibre and fibre fragment can be used interchangeably. But microfibre in this context is different to microfibre meaning a very fine fibre. So if microfibres are released from synthetic textiles such as polyester, then they are also under the umbrella of microplastics. Next slide, please. So where do microfibres come from? So the sources and pathways of microfibres are really complex and interconnected. Textiles release microfibres throughout every stage of the life cycle. So during manufacturing, consumer use, including laundry, wear, and drying, and at the end of use stage as well. So during recycling or waste. So to start with, when textiles are washed by consumers in laundry, microfibres are generated and enter the wastewater. Millions of microfibres are generated from each wash, which becomes part of the household wastewater. Wastewater treatment plants can filter some of these out. Some plants have over 90% efficiency, but due to the extremely high numbers of microfibres generated and entering plants in the influent, we still see millions passing through wastewater treatment plants into the environment. And a large percentage of global wastewater is untreated anyway. So it's been estimated that approximately 6.5 million tons of microfibres are generated through this pathway every year. So this is where the focus of the topic was originally, the release of microfibres during laundry. It's probably where you might have heard of the issue. But what has become clearer with recent research is that this is not the only source of microfibres. Microfibres can be generated across other life cycle stages as well. So during manufacturing, high numbers of microfibers are generated throughout the production process. So spinning, weaving, cutting, sewing, and especially the wet processing and dyeing stages release extremely high numbers of microfibers to wastewater. And again, some of those will be collected by on-site treatment and others will enter the environment. Microfibers that are generated to wastewater, either during consumer laundry or manufacturing, can potentially be captured by wastewater treatment, as I mentioned. However, sometimes the microfibers that are captured can then become part of sludge fertilizer, which is then deposited onto soil, and so they can enter the environment through another pathway. Microfibers are also generated during tumble drying, so released from dry events into the air, which have very little filtration. Some researchers showed that a 15-minute tumble drying cycle can release over 500,000 microfibers into the air. And during daily wear, so abrasion while we wear textiles causes microfibers to enter the air. Research has now shown that the levels of microfibers generated to air during wear may be comparable to the numbers that are released during laundry to water. And the numbers of microfibers generated varies depending on fabric characteristics, which I will go into a little bit more in a bit. Next slide, please. So where are microfibers found? So microfibers are released into the environment and they are now found throughout the environment. Essentially, wherever researchers look for microplastics or microfibers, we find them. So oceans, rivers, lakes, mountains, hundreds of species of animals, essentially every animal that has been sampled, and now also humans. So they can enter the human body through inhalation from the air or ingestion from food or drink. And once in the gut, they can then translocate to other organs in the human body. Because these particles don't degrade, they can accumulate in the environment and the food chain. So species at the bottom of the food chain can ingest these particles and they can then transfer up the food chain towards humans. The concentration of these particles in the environment varies depending on where you sample. Next slide, please. So once consumed by species in the environment, they may then go on to have toxic effects. There are still significant knowledge gaps regarding the toxic impact of microfibers, but what we do know is that the effects can be physical, chemical, or biological, which is similar to other microplastic types as well. So physical effects means the blockage or irritation of organs. Chemical means effects that are as a result of the leaching of chemicals from the particles, which in the case of microfibers can include things like chemical finishes or dyes used in the manufacturing process, many of which are known to be harmful to the environment. So the chemical effects can vary depending on which chemicals are present in the fiber as a result of the manufacturing process. Or the effect can be biological, meaning the transport of harmful microorganisms. So a range of negative health effects have been found, including tissue damage, reduced growth, and overall increased mortality. Most existing research into microplastic toxicity has focused on spheres or fragments. Fiber fragments can have different shapes, size, surface area, or chemical processing. It is not yet known how the toxicity of fiber fragments can compare to other forms of microplastics. That's despite microfibers being one of the most common form of microplastics in the environment. So it is known that these particles can have negative health effects in lab studies on species, but it is not yet known how this relates to their concentration in the environment. So it's not yet known what effect is happening in the environment. So more research is required to understand realistic exposure effects. Next slide, please. So negative health effects have been found in animals, and we know that microfibers are consumed by humans. But what are the effects towards humans? So humans can ingest or inhale microfibers from the air, drinking water, or food. And microplastics, including fibers, have been found in humans. The effects towards humans are still unknown. It's a lot harder to study the effects towards humans than it is on in lab studies on animals. But there are concerns over the effects of microfibres on hormone disruption, airway damage, intestinal disturbance, and the transmission of bacteria. Next slide, please. As well as concern over their effects on animals and humans, there is a newer concern that microplastics, including fibres, may influence climate change. Microplastics have been found to alter the carbon storage potential of the ocean, greenhouse gas emissions from soil, and atmospheric cooling in the air. This at the moment is a fairly unstudied link, but there is definitely a cause for concern over the effect of microfibres and microplastics on climate change. Next slide, please. So it's well known that synthetic textiles such as polyester and nylon release microfibres, and these synthetic particles will not biodegrade and can persist in the environment for thousands of years. Fabrics made from cotton or cellulosic material may also shed microfibres into the environment, and although these materials are often thought of as biodegradable, environmental studies find that natural microfibres tend to be more abundant in the environment than synthetic fibres. So the graph on the right shows a study which collected microfibres from environmental samples in the coast of Kenya and Tanzania. And as you can see, the highest concentration of microfibres was found in cotton, followed by polyester. So although cotton and cellulose are biodegradable in their natural unprocessed state, chemical finishes and dyes that are applied to these fibres during manufacturing may reduce or delay their biodegradability, meaning that they can persist in the environment for longer than we would think, and can no longer really be considered natural after the manufacturing process. And when they do biodegrade, they may then leach harmful chemicals that were used in manufacturing into the environment or into species that have ingested them. So negative health effects of natural microfibres have been found in animal species, comparable to the effects of synthetic microfibres. So this means that the issue of microfibres is not exclusive to synthetic materials. We do need to also take into account the pollution of textiles that include cotton and cellulosic materials. But obviously these particles are not technically classed as microplastics. Next slide, please. So in summary of the research, microfibres or fibre fragments are now prevalent in the environment, found across most ecosystems and hundreds of species. Both synthetic and natural microfibres are found in the environment and can cause potentially negative health effects on animals. Microfibres are found in the human body, but the effects are still unknown. The level of fibre fragmentation of a textile across the entire textile life cycle varies depending on textile characteristics. So some fabrics and textiles can shed more microfibres than others based on things like the composition, fabric structure, yarn type, finishing processes, and dyeing can all have an effect on microfibre loss. So that forms the basis for one of the solutions that has been provided for the issue of microfibres around designing fabrics in a way which causes them to generate less microfibres over their life cycle. And that is where the focus of the Microfibre Consortium is. Next slide, please. So I'll speak a little bit now about what the textile industry and the Microfibre Consortium are working on to address the topic. So the Microfibre Consortium, or TMC, is a research-led sustainable textiles NGO. Our aim is to convene the fashion and textile sector to combat fibre fragmentation collaboratively. The issue is complex and spans the entire industry and supply chain. So that's why we see collaboration as being really important in finding solutions. We have strong links with academia and research organizations, and we want to connect that research with the industry. So we have over 100 organizations who've joined our commitment, and that includes clothing brands, retailers, suppliers, and research organizations. Now, our aim is to align the industry to combat the issue together, develop root cause understanding of the issue through testing, and eventually provide mitigation solutions. And there are two ways that we see mitigation happening in the industry. Firstly, through the design and development of fabrics. So this means upstream solutions to enable textile suppliers to produce fabrics which generate less fiber fragments over the course of their life cycle. And manufacturing, so improving manufacturing wastewater treatment to reduce pollution that is generated during the manufacturing process to the environment. So we're really keen to ensure that the solutions that we do produce are realistic and applicable to the industry. And that's why we see working with the textile industry as key to achieving that goal. Next slide, please. So we have been working in collaboration with ZDHC to tackle microfiber release during wastewater. We have set up a task team with TMC, ZDHC, and other representatives from across the textile industry. And our objectives are to firstly start quantifying release from manufacturing. Most of the research and the work done so far is being focused around the release of fiber fragments during laundry. What we want to do is start really investigating the other sources of microfibers in as much detail. So the release of microfibers during manufacturing. Start to report and track improvements over time, including the efficiencies of different treatment technologies to essentially try and identify hotspots and ways to improve wastewater treatment plants. And over time, start to reduce release from manufacturing by providing best practice guidelines to manufacturers. Next slide, please. So the other aim, as I said before, was to start developing solutions for fabric design to essentially create lower shedding fabrics. So to achieve this, we developed a test method to measure microfiber loss from finished fabrics during laundry. When organizations sign up to TMC, they are required to test a certain number of their portfolio of fabrics each year using this test method. So this is a standardized test method developed by TMC, the University of Leeds, and the European Outdoor Group, and was validated through a peer-reviewed interlaboratory study. So the test simulates laundry, and it measures essentially how fabrics shed during laundry cycles. So fabrics are washed in a gyro wash, the liquor is filtered, and the microfibers are weighed, with each fabric being repeated 8 times. And the images show some of the equipment used. And this is equipment that is really commonly used in the textile industry to assess things like coloration and color fastness. So the data is then uploaded to TMC's data portal alongside really detailed fabric specifications of the tested fabric. So composition, structure, finishing and dyeing methods are all recorded for each fabric. We record over 50 variables for each fabric. And then this is all uploaded to TMC's data portal. Next slide, please. So we currently hold 1,311 fully tested fabrics in the data portal, with 250 waiting to be tested. Each fabric is tested at least 8 times, so we have over 10,000 individual data points from 49 different signatories. 45 independent labs perform this test globally, and 10 signatories have accredited in-house labs, with 182 technicians currently accredited to perform the test. We average around 50 to 60 fabrics uploaded each month by our signatories at the moment. So we have a really large amount of data. Next slide, please. So this data that we have, so this is the fabric specification and the microfiber loss test data can then be used to help develop lower shedding fabrics by understanding the effects of fabric characteristics on fiber fragmentation. So what we've been doing is using this data set containing 1,300 fabrics to perform a really detailed statistical analysis using machine learning, big data analytics to understand the root causes of fiber fragmentation, which variables increase or decrease fiber fragmentation and which have the strongest effect, so that we can then start developing a set of guidelines for the industry on which design choices to make when designing a fabric to create a fabric which generates less microfibers over the course of the life cycle. What we can also use the data for, the signatories can then use the data to understand the shedding rates of their fabrics, which of their fabrics are high or low shedders. They can compare their fabrics to similar fabrics in the data portal to kind of understand the shedding of their portfolio and assess which fabrics need to be assessed and worked on. All the data is completely anonymous. We only use it for internal research. But again, we can use it for large-scale statistical analysis. So last year we carried out a assessment of recycled polyester. We analysed all the recycled and virgin polyester fabrics in the data portal to assess if the move from virgin polyester to recycled polyester was influencing fiber fragmentation. And the report of that work and all the other analysis we've carried out is available on our website. Next slide, please. So that was a quick introduction to microfibers and TMC. As I said, there's a lot of content on our website if you want to learn more about our work or our research, or if you would like to get involved or find out more, just feel free to email me or my colleague Anna if you would like to get involved with the consortium. I don't know if I went too fast or too slow then, but is there time for some questions now, Morgan?
Yeah, it looks like we have about room for about one question. And we have one in the chat, which is asking, do you feel like finishing chemistries and softeners on fabric can skew the final weight of the test method?
Yeah, good question. So I think what this means is we use, because we measure the microfibers that are released during the test method, if a chemical finish is being used on that fabric, then that could also be weighed and influence the results. We have considered that. I think in general, the chemical finishes that are used on a fabric should remain on the fabric and not be released during the first wash. I think it might influence the weight of the fibers, but I think if that chemistry becomes part of the pollutant and it weighs more, then that should also be measured. But we do also see that some chemical finishes actually reduce the level of fiber fragmentation as well.
Amazing. Well, thank you, Elliot, for that answer and for giving this fantastic overview on microfibers and all the work that TMC is doing. With that, I am going to move us forward to our next speaker. So Analoli, feel free to take it away now.
Thank you so much, Morgan. Hi, everyone. It is very nice to be here with you. My name is Analoli del Cueto, and I am a junior consultant at Ohana Public Affairs Consultancy. We can move to the next slide, please. So here is briefly what I'll be discussing with you guys today. I'll introduce a bit about Ohana and who we are if you don't know us yet. And then I'll move right on to the partnership or collaboration that we have with TMC? How do we approach the public affairs with TMC? What is our goal? How are we going about it, basically? And then I'll just give a brief rundown of the most important piece of legislation that we have coming up for textile products, which is the Eco Design for Sustainable Products Regulation, and how we are also going about our work there. So we can move to the next slide. And the next slide. Thank you. So as I mentioned, we are Ohana Public Affairs Consultancy. We are a boutique public affairs consultancy specialized in sustainability with a very strong footprint in the textiles and apparel industry, since at the moment, most of our clients are in that sector. We are based in Brussels, very nice and close to the EU institutions, the policymakers and stakeholders. And some of our clients in the textile industry, you might have heard of them: H&M Group, Hugo Boss, BF Corporation, and of course, TMC, the Microfibre Consortium. We can move on. And move on as well. So as mentioned, also, this is a story of collaboration, basically. And I think it's very good that Elliot went before me, because basically we knew from the beginning that the TMC brings together the global textile sector to limit fiber fragmentation and microfiber pollution, and that it connects, as he also mentioned, academic research with real-world supply chains. So brands, manufacturers, and therefore a last link was needed in order to make sure that the knowledge gathered by TMC reached in an effective manner the policymakers to develop effective legislation, to actually have an influence or yeah, a say in how the legislation in the European Union is developed. We can go to the next slide. So now I'm going to talk a bit more about why why are we doing this? Yeah, as I said, to create that link that was missing, but also, of course, like the main overall objective is, as also Elliot mentioned, to reduce fiber fragmentation and environmental impacts of microfibers. And that is the main goal that we're going about. How we decided to do it with the TMC is to create a TMC policy committee. And so this policy committee is formed by TMC members that are mainly textile manufacturers at the moment. The scope that we are focusing on is microfibers in EU legislation. So we monitor the policy developments, we share insights, and align on positions amongst the groups, the group participants. We also translate the scientific knowledge of non-experts working on policies, such as myself. I have no scientific background in microfibers or microplastics, but I do have a legal background. And so that collaboration between having such a specific expertise from the TMC side to also working in this more of a legal framework is what we believe that makes it work, knowing also like the European Union processes, how policymaking works, how policymakers work, and how to bring that collaboration to be as fruitful as possible. We also monitor global regulations. However, that is more, on a monitoring level, more to know what regulations around the globe are also being developed. And so the last point would be the what. So as I mentioned already, so the goal of the TMC Policy Committee and the work that we're doing is towards sharing the scientific evidence and in practical insights to policymakers and stakeholders to achieve feasible, effective legislation. So the findings that Elliot has mentioned, on microfiber impact on testing on the different solutions, but also, which is also very important, the knowledge gaps that are existing at the moment. For instance, the health effects that are still unknown overall, and the research that is still ongoing, that to also portray the fact that there is still research to be developed, and also that funding can go into that direction. So in general terms, of course, positioning the TMC as the valuable and knowledgeable partner that it is in this also very specific subject matter, because microfibers is niche within the textile sector as well, and bringing this educational narrative around microfibers to the policy debate. We can move forward. So so far we have had very positive progress, if I may say so myself, with the TMC policy committee. We started our work in May, and we've defined our policy engagement approach, the policy priorities that we want to focus on, because of course there's a lot of things going on at the same time. And we have initiated the outreach, focusing on various pieces of legislation. But yeah, it has also been this collaborative work on where to focus on and where to target also the resources within the policy landscape. We can move forward. Yeah, so even though so our work with the Microfibre Consortium focuses on microfibers, and there is where our targeted approach lies. However, we know that microplastics is also, well, it is on top of politically speaking, on top of the agenda. And there are also various things going on only focusing on microplastics. But because our work with the TMC focuses on microfibers, I won't touch upon this slide that I have with an overview of the legislative development so far of microplastics in EU legislation. Yeah, we can move forward. Exactly. So now I'm going to dive into, as I mentioned, one of the most important pieces of legislation that we have at the moment regarding regarding textiles. So that is the Eco Design for Sustainable Products Regulation, or ESPR, that I'm sure a lot of you guys have heard of. A bit of context. So this is the piece of legislation that has been in force since July 2024, so not that long ago. And it is very important to keep in mind that it is a framework to establish eco design requirements for products. So all type of products in the European Union, you name it, from furniture to electronics and textiles. So what the European Commission envisioned is to have this framework, and then since the different products are very different from each other, they will have what they call delegated acts for each product or product group, in order to establish eco design requirements for that product or product group itself, because they were, I mean, the characteristics or the similarities between a phone and a sweater are very, very few, to say none. So That is how they are going about it. Why this piece of legislation is very, very important. It is because it is a market access legislation. And that means that if a product, if there's a delegated act on a certain product that sets eco design requirements, they are mandatory. So if a product does not meet the eco design requirements, it won't be able to be sold in the EU market. So textiles, garments, and footwear are categorized as this priority product group because the European Commission has been analyzing which products in the EU market have the most negative environmental impact, and textiles are one of the main ones. And so the process at the moment of this delegated act on textiles is being developed, like it's in the making at this as we speak, I would say. We are expecting the design requirements for textiles to be enforced around 2028, but as I said, this is an ongoing development and the timeline varies constantly from month to month. But approximately around 2028, we would have eco design requirements for textiles. We can go forward. Exactly. And so, as mentioned, since it's being developed at the moment, there are a lot of technical conversations around textiles because of this delegated act on textiles. The ESPR framework that I mentioned did allow the possibility for the Commission to set eco-design requirements on nano and microplastics. And this can come in the form of to limit microplastic release, so emission limits, limits in pre-industrial washing machine filters, but it can also come in the form of performance requirement to address the release of nano and microplastics through the release during relevant product life cycle stages, so during manufacturing, transport, use, end of life. And so what this means is that the European Commission opened the door for this possibility. But as I said, since it's in the making, we don't know in the end if we will have precisely eco-design requirements on this, limiting the release of microplastics for textiles. But I can tell you a bit of the initial approach, I would say, that the Commission is taking regarding microfibers, microplastics. So it is true, and it has been established that microplastics is a key environmental concern under pollution from textile fragmentation. However, they do acknowledge that there is scarce data on production and disposal stages, and there are challenges in quantifying emissions. And at the moment, they have identified standards only for microplastics and not microfibers. One of our work within the TMC policy committee is also what Elliot was mentioning, to bring forth the fact that all fibers shed, that that it is not just microplastics. It is true that microplastics are in the eye of the hurricane politically, but it is very important to take into account all the facts, I would say. And so that is also the collaboration stage between the research, the industry, the policymakers. So that is what we are, and that is why we're focusing on this, because this would be quite impactful as well for the textile industry. But as I said, TBC. We can move forward. Exactly. So this comes back again with my story in the beginning as well of collaboration. So the internal experts within the TMC, but also experts from the brands, you know, it is necessary to have the conversation, to put everyone at the table, but also to we call it to translate what we are trying to say, because sometimes and that happens to me as well. Sometimes I hear very scientific technical people from the TMC, and I'm like, okay, wait, because I have no idea what you're talking about. And so that translation from technical to an actual policy ask, it's the process where Ohana and TMC, we come together in a very nice collaboration, I would say, to then actually make sure that, yeah, for instance, microfibers are taken as a whole and just microplastics, to have actually effective legislation that can be established in reality and not just theoretically. So yeah, that was my part. Thank you. I think I went quite fast.
Sorry, I think I was muted. But no, that was perfect, and that just means we have more time for Q&A, which is always fantastic. So thank you so much for providing that overview. We do have some questions that were popping up in the chat. So one of them is, how does TMC's policy work impact textile companies that also operate outside of the EU? Are there loopholes, and are there relevant partners in other parts of the world, like in North America?
So the textile partners that we have are not only, so there are manufacturers or brands that are not only in the EU, so also brands from the US. The thing about the ESPR is that it will impact the EU market, right? So all the products that want to be sold in the EU market will have to comply. And by having brands in the conversation also from the US, for example, it will impact them. What if you want to sell in the EU market, this will impact you. So this is, I mean, if we translate all the knowledge that the TMC has successfully to the policymaker in the development of this legislation, it will definitely affect the whole textile industry. Yeah.
Great. Well, thank you. Okay. And I also want to welcome Elliot back to the conversation for the next part of the Q&A, because we have some questions in the chat for you as well. So Elliot, is the TMC doing any hazard/effects testing to understand the safety of released fibers?
Yep. So we're not doing that work, but we work and communicate closely with academics and research groups that are doing that kind of work, so that we can stay on top of where the state of the science is and relay that to our signatories and to those that are interested. So we don't do that work directly, but we are indirectly involved with those that do.
Great. Okay. Thank you for sharing. And then we do have one more kind of policy related question. So how do you work together with your different stakeholders to decide on timelines for policy making steps?
So at the moment, for the ESPR Delegated Act on Textiles, there's this research being developed by the European Commission, and there are stakeholder consultations for which the Commission sets us deadlines. And so, for example, we have in our policy committee meetings, we set ourselves internal deadlines so that we meet the European Commission deadline. So, for instance, our next deadline is the 3rd of March. And so we work until that time so that the feedback can come back and forth. So I propose them a set of feedback, and they come back with comments and or changes, of course, with their expertise, with their positions. I integrate them, and then in the end, I will have to submit by 3rd of February. But we move according to the the timeline that the Commission has is working with.
Thank you so much for that answer. And then Elliot, another one more directed to you, so we're going to pop back that way. What is the state of science regarding the size distribution of microfibers released during the life cycle of textiles?
Yeah, great question. A lot is known about the size distribution of microfibers that are released during laundry, because that is really well researched. There's been lots of research groups investigating that. There is some really sophisticated test methods to investigate that source of microfibers. And at that stage, the size distribution varies really, depending on the composition of the fabric and the yarn structure and things like that. A lot less is known about the size distribution of microfibers that were released during manufacturing or during the end of use stages, just because there are a lot less research has been carried out on those life cycle stages. I think what is interesting as well is that microfibers, when they're released into the environment, can then fragment further into smaller fragments of fibers. So the size that a microfiber is generated at into the environment is not the size it will stay at forever. It will then become smaller and smaller fragments down to the nano scale. And nanoplastics is another topic, which is kind of a topic on top of microplastics, because they're so much harder to investigate in the environment, because the size detection limit of a lot of the test methods are unable to measure them. So we really need to understand a lot more about nanoplastics and smaller fragments in the environment. Yeah.
Great. Well, that's super interesting. I wanted to build off your point when you were mentioning that we know quite a bit about released from laundry, but not other parts or other ways that microfibers can be released. So what actionable steps do you think the industry can take to reduce the release of microfibers from their products throughout manufacturing, throughout distribution, and before we kind of reaching that laundering step?
Yeah, so our aim really is to provide a set of these, suggestions and guidelines, best practices to fabric designers or suppliers on ways in which fabrics can be designed to be lower shedding, but it's still a really new field. So we're still really in the understand phase. We need to be doing research to understand exactly how different design choices influence fiber fragmentation before we start then implementing them. So as a result of the recency of the field, it's not exactly there yet, but that is the goal and that's the aim of where we want to get to at the design stage. But then there's also things like improving wastewater treatment of on-site effluent treatment plants in textile manufacturers as well. That it's well known how that can be improved already.
Got it. Well, it's great to hear then that you guys are doing all this fantastic work so we can reach that place of actually having a plan that we can implement to make those actionable changes within the industry. So we have quite a few more questions in the chat. So I think I'm going to pull this one next. So Analoli, this is probably for you. For bio-based plastic, will there be any regulation for new chemicals from bio-based feedstock?
From the top of my head, I cannot think of anything as specific, but would it be okay if I come back on that question? Yeah, I think I can email you, Morgan.
Yeah, that's fine. And then I can share that answer out with the rest of our audience so they all have that as well. So moving forward, is there a plan to add more fiber options to the TMC data submissions for a broader field of study, such as cellulose acetate?
Yeah, so we allow any fiber types to be uploaded to the TMC data portal. There's no restrictions on what that has to be. off the top of my head, I don't know if we've had any cellulose acetate uploaded to the TMC data portal, but we certainly would be interested in including that. Yeah.
Okay, great. Well, that's good to know. And we can expand that network and kind of all work together to grow that. We know that we're only going to have more success in kind of combating this global challenge. So another question we have is, does your work also involve interacting with domestic water public utilities as well as the manufacturing companies, or is it more between the two of them?
Yeah, good question. We haven't worked with domestic water public utilities, but we know so that when we're working with the wastewater treatment plants, we've been interacting with manufacturing companies for their on-site wastewater treatment plants, which are completely different to domestic water public utilities. So no is the answer. We haven't worked with municipal wastewater yet.
And do you work as well with some of the manufacturing companies, or is your membership and your partners at the TMC more based on like your end of life, so your retailers and brands?
No, we work closely with manufacturing companies as well. Yep.
Okay, fantastic. Great to know. Another question we have, which I'm actually quite interested as well to kind of see what both of yours takes is how can we prevent any spread of misinformation or fear mongering about this topic as it gains more attention, not only within the scientific community, but also within the general public and media?
Yeah, I think we just have to be honest about what we know and what we don't know. And it's okay that we don't have the answers to everything at the moment. It's a new field. It's compared to some other sustainability initiatives, it's a new field. So there is significant research gaps, but I don't think that means that we have to put everything on hold until those gaps are filled. I think we know enough to know that it's a issue that needs addressing. But we just have to be honest with what is known and what isn't known at this stage, I think.
I totally agree. Also, I feel like talking to policymakers and to stakeholders, also the knowing what we are referring to when we say microfiber, when we say fiber fragmentation, microplastic, to also be clear on the terms. I think it's helpful to everyone to know what we are actually talking about when we say one thing or the other. Is one of the things that it struck me a lot, because also then going to the supermarket, I also saw microfiber cloth and I was like, what? So also for the average consumer or someone that is not an expert, sometimes just I think having in your mind, with the help of TMC and actually technical people to tell you and getting informed of what you're talking about, it's super important to not misspread this information.
Yeah, well, I'm really happy to hear both of you kind of say that, and gets back to that big secondary point of this webinar series, which is not only microplastics and microfibers, but also thinking about how we can really collaborate to solve those issues and make sure we understand the state of the science about these challenges, so that we can develop solutions rather than just kind of focus on the fact that these challenges are large and they can be a bit daunting. But if we work together and kind of make stepwise increments to find solutions, we really can work to solve these challenges. So on that note, we are just about out of time. So Elliot, Analoli, I want to thank you both so much for joining this webinar today and sharing your expertise and some of the great work that both of your organizations are doing. And of course, thank you to everyone else on this call as well for tuning in and asking such great questions. We hope to see you at a future webinar or other Change Chemistry events, and have a fantastic rest of your day. Thank you all.
Thank you.
Thank you. Bye.